Size and cuvette volume really matter in getting fast gas exchange measurements from systems. This calculator will help explain why. The first page here is a dilution model where we've got two chambers, a 14 cc and an 80 cc, and we're with a similar flow rate, with 300 milliliters a minute flow rate, we are changing the concentration of the gas in the chamber. So dark starts out as the initial concentration. We're adding essentially clear or white gas in and watching how long it takes for the chamber to reach the final concentration. You can see that the smaller volume chamber, blue, reached the final concentration in less than 20 seconds, while the larger 80 cc chamber is going to take about 60 seconds or more to reach it. This is just a fundamental process of exponential dilution, where the flow rate and volume are the only variables that really matter. So smaller is better, and the only way to change it is by increasing flow rate or making the chamber volume smaller. Okay, that's the message of this page. Now, if we go to the Cyrus 3 model, this is the model of two different approaches to measuring gas exchange system, to designing gas exchange system. In the Cyrus 3 model, we have a very small cuvette chamber, 14 cc's, and we have the ergas back in the console where they can be maintained at a constant temperature and keeps the cuvette head small and light. We pump the gas up to the chamber and back to the console. The alternate approach is to have the ergas, the analysis and reference erga, in the head of the cuvette. It makes the cuvette larger, heavier, and a higher volume. So this calculator here is simulating what happens if you put a leaf in with a given assimilation rate. I'm going to increase this to 15, and then we'll hit the calculate button and see what happens. So this blue curve is the Cyrus 3 model, green is the erga in the head model, and you can see that the blue reached its final or its response time. With this is the calculation of the time to reach 99% of its final value. In less than 20 seconds, 17 seconds, we reached that. The larger 80 cc volume took 48 seconds. Okay, and one point to make here is that we do have a slight lag as the gas from the cuvette has to travel back to the analysis erga in the console. At the sample rate of 100 milliliters a minute, that's about 10 seconds. And we have that, that's what this 0 point represents here. But we still, because our cuvette is so much smaller, we get we reach the final response, the final concentration, so much quicker than this larger chamber. One thing that you can do, as I said previously, you can increase the flow rate to increase your response time. So if I increase the flow rate of this erga in the head design to 800 milliliters a minute, I can get the response time to be almost the same as our small volume chamber. But when I calculate, let me show you what happens here. The green curve, because we're diluting with so much more chamber gas, chamber flow, the delta CO2 is much, much less. So where the Cyrus 3 design gives you a delta CO2 of 30 ppm and a time response less than 20 seconds, to get the same response time in the erga in the head design, you have to increase the flow rate, and it drops the delta CO2 to 10 or 11 parts per million. So you can see there's lots of reasons to choose a small head design. You can play with these numbers, you can change each of the sliders and figure out what your what different parameters you might find in your particular gas exchange system.